Hello students, welcome to the next lecture of the ordinary differential equation. In the last lecture we had seen the questions based on the variable separable method, the ordinary differential equation that can be solved by variable separable method and performing the integration, direct integration. In today's lecture we will talk about the homogeneous differential equation and the solution to homogeneous differential equation. So what are the homogeneous differential equations? So homogeneous differential equations are the equations of the type where we can write the equation in such form, in this form, where we can take dy by dx on one end, and on the opposite side we can write the terms in the fraction form, that is in the numerator and denominator form, with one condition, that all the terms in the numerator and all the terms in the denominator must have the same degree. So what we mean by the degree, that is the power of the variables. So let's check whether this is an homogeneous differential equation or not. So as we can see, this equation is written where the left hand side is only dy by dx, and on the right hand side we have all the terms in the fraction format. Now let's check the degrees of all the terms. So this is the first term, which is a 3y square. So this is 3y square. So the degree of the term is the power of the variable, which is y square. So the degree is 2 for the first term. Now for the second term, this is twice of x and y. So we have two variables, x and y. The degree of x is 1 and the degree of y is 1. So the combined degree of this term is also 2. That is 1 plus 1, 2. Now in the denominator, let's see, in the denominator we have again 2 of xy. So this is 2 of xy. Again the degree of x is 1 and the degree of y is 1. So the combined degree of this term is 2. And the last term, which is x square. So the power of this, the power of the variable in this is 2. So the degree is 2. So the degree of all the terms here we can see that is same, which is equal to 2. So this will be termed as the homogeneous differential equation. So any differential equation, ordinary differential equation that can be written in this form will be known as homogeneous differential equation. So now let us see the solution of this homogeneous differential equation. To solve this homogeneous differential equation, we need to do one substitution, that is we need to substitute y is equal to vx, and as we are substituting y, then we have to replace dy by dx also with v plus x dv upon dx. By performing these substitutions, we will be able to convert this given equation into the variable separable form. And once the equation is converted into variable separable form, we can solve it by performing the direct integration. So just to solve this homogeneous differential equation, first we need to write the equation into the standard format, which is this. Then we need to substitute y with vx and dy by dx with v plus x dv by dx. After performing these substitutions, we need to convert the equation will be converted into variable separable form, and then we will perform the direct integration. So let us see the solution to this equation. As we can see in this equation, we have performed the substitution y as vx and dy by dx as v plus x dv by dx. So just by performing these substitution, the equation becomes something like this. You can note down the equation and perform the substitutions by yourself and verify the solution. Now we need to convert this into variable separable, so we need to separate the variables here. So we will try to separate the variables. That means we will keep all the x variables on one side and all the y variables on another side. You can see the solution. It's just by solving this, now we are capable of converting this into the variable separable form, where on the one hand we have only values of x, and on the other hand we have only the values of the variable y with dv. So this is dx with all x terms, and this is dv with all v terms. So in this way we could we could convert this into the variable separable form. Now as it is converted into variable separable form, we can perform the direct integration onto the equation on the LHS and onto the right hand side. So we can see the LHS is 1 upon x integral, so this can easily be converted into log of x. So the integration of this 1 upon x will be log of x. To solve right hand side, we need to perform a substitution. So let us see what is the substitution we need to do. We need to perform v square plus v, which is the part in denominator, as t. So now this will be 2v plus 1 dv will be dt. So the numerator will be dt, the numerator will be converted to dt, and by substituting, so you can see this is we have substituted v square plus v dv. So 2v plus 1 dv will become dt, right? So so performing these substitutions, so we have substituted v square plus v as t and 2v plus 1 dv as dt. The equation can easily be solved. The LHS is log of x and the RHS will be log of v square plus v plus c. So 1 upon t, the integral of 1 upon t will be log of t. Then we will substitute the value of t back, which we have assumed. So this is the solution of the homogeneous equation. Let us see one more question based on the homogeneous equation. So this is x sine of y upon x dy is equal to y sine y upon x minus x dx. So first we need to perform the substitutions. We need to substitute v as y as vx, and then dy upon dx as v plus x dx. So this is equal to v plus x dv upon dx. So just by doing these substitutions and solving the equation, and we need to cross whatever is mean, you can see the solution and you can match the equations. Finally we could see that this is converted into variable separable form. So this is converted into variable separable form. So sine of v with dv and minus of 1 upon x with dx. So the variable terms with variable v is with dv only, and terms with variable x with dx only. So now just performing the direct integration, as we know that the integration of sine of v is minus of cos v, and minus of 1 upon x. 1 upon x will be log of x. So just by performing the integration and finally replacing back the substitution of v, which is y upon x. So this is the final solution of the given equation. So you can pause the video anywhere you want and you can relook the solution, and you can ask me any query if you have. Let's see one more question onto the homogeneous equation. This is dy by dx. Again performing the substitution, y is vx and dy by dx, and just by performing the substitution and converting the equation into the variable separable form. So once you will perform the substitution, you will see that the equation can easily be converted into variable separable form. So here finally we have this variable separable form. Finally we have this variable separable form, 1 upon under root 1 plus v square dv is equal to 1 upon x dx. So once it is in the variable separable form, we can perform the direct integration. So now you can see that the integration of this is sine inverse of v, and 1 upon x is log of x. And finally we will replace the substitution v by y by x we have done earlier. So v will be replaced by y by x. So this becomes sine inverse y by x is equal to log of x plus c, which is the final solution of the homogeneous differential equation. So that's it for the lecture. In the next lecture we will talk about the equations which can be reduced to homogeneous differential equation, and then we will try to solve these equations. Thank you so much.